Hi viewers, this is Dr. Gunamanjana and you are watching video with me on database management system. And mainly we are going for the subject DB that is covered for the fourth semester BTech Computer Science student. In this subject, in our last video, we have seen the transaction and in this video we'll be going for this concurrency control. And the outline of this presentation is like this. First we are going for this log-based protocols. Next, we are going for the timestamp based protocols, validation based protocols, multiple granularity, multi-version schemes, insert and delete operations, concurrency in index structures. These are the things. Anyway, some of the things we are going to discuss in this video. Let us have an idea about what is this log-based protocols. Imagine we are going for this concurrent access. That means at the same instance of time, more than one person is going to access the same maybe account or going for this same transactions. So lock means it is a mechanism or lock is a mechanism to control concurrent access to a data item. For controlling that one, we use this lock base. That means whenever I need, I have to lock that one. Once I complete, then I have to unlock that one. That is called lock based. So this locking, unlocking is done on the data item. Okay, suppose Q is the data item on which I have to go for the different operations like read operations, write operations, or both read and write operations, or one of them. And broadly, we have divided into two type of things, two type of modes. One is the exclusive mode, that is operation X, and second is the shared mode, the operation is S. So first letter we are putting S and X. What happens in the exclusive mode? Data item can be both, we can read as well as write. So this is called the exclusive, right? You are getting. But while you are going for the shared mode, there we can only read. We cannot perform the write operation there. Okay. So then when you need this lock operations, these lock requests are made to the concurrency control manager by the programmer. Right. Transaction can provide or it can proceed only after request is granted. Suppose you are granted with the exclusive code, then you can perform the read and write. And once you complete, then you unlock something will be available for others. Now, what is the compatibility issue and what is the log compatibility matrix? You see, if more than one person want to read operations, it is nothing going to tamper, nothing going to happen. So you read the same thing, I also read the same thing. So it is compatible or SS it is true. But if at least one write operation is there, then before I write, if you read, you will not get a consistent or you will not get a correct thing. Okay. So like that, S and X false, X and S false, and X and X obviously it is false. That means only when both the things are going for only the shared mode, in that case it is true. The same thing is arranged here in the below. A transaction may be granted a lock on an item, say data item that is Q, if the requested lock is compatible with locks. Say for example, so both of them want S and S. It is compatible. It can be allowed. If both of them want X and X, on the same data item, it is not possible. Yeah. So one has to lock, finish his operations, then unlock, then only it is available to the other person, right? This is the idea behind this thing. So any number of transactions can hold shared locks on an item. Shared lock means you are reading. So by reading, no data changes, nothing is happening. So it is not compromised. So we don't have any compatibility issue. We don't have any compatibility issue. But if any transaction holds an exclusive on the item, no other transactions may hold any lock on that. That means suppose I got exclusive code on any data item queue until I unlock because it is locked by me. Until it is unlocked, it cannot be shared to others. This lock arrangement cannot be given to others. That's the meaning. So if a lock cannot be granted, the requesting transaction is made to wait till all compatible locks held by other transactions have been released. Okay. So then you see, so when lock cannot be granted, then it has to wait for some times. How long it will wait? Until all the incompatible locks held by other transactions have been released. So the lock is again granted. Okay? So this is the idea. Now let us study in details about the log-based protocols. Suppose I'm going for a transaction T2, where I'm going for a shared log to the data item A. Then shared item I can only read, so I read A, then I unlock A because I have already read that one. Then lock, I go for the shared log, data item B, I read that one, I unlock B, and I go for displaying A and B, A plus B, right? So this is the thing what we are doing uh, in the log-based protocols. So locking as above is not sufficient to guarantee any serializability. That means if A and B get updated in between, the read of A and B displays the sum would be wrong. The meaning is like this. Suppose you read A, before that some update is done on A. You get it now. So if it is not locked, unlocked, all the things are not done, then you may get a wrong data on that one, right? The locking protocol is said to it is just a set of rules followed by all the transactions while requesting and releasing locks. The locking protocols restrict the set of possible schedules also. Now, we are having the two phases of locking protocol. So, these protocols ensure conflict serializability schedules. What is the equivalent schedule? They suggest that one. Now, what are the two phases? One, we are having the growing phase or increasing phase. Other is the shrinking phase. What is there in the growing phase? That means a transaction may obtain one lock, but it may not release locks. So I have one, so I have S, I may go for exclusive. That means I'm not releasing anything. I have one, I'm getting another one. This is called the growing phase. The shrinking phase, suppose the transaction may release a lock. I had say schedule the shared lock S, I release that one, and I may not obtain. I am not interested to obtain a lock. In that case, it is a shrinking phase, right? And the protocol assures serializability, and it can be proved that the transaction can be serialized in the order of their lock points, the points where the transaction secured its final lock. Then in the two phase of locking protocol, we are continuing. There can be conflict serializable schedules that cannot be obtained if two phases locking is used. Try to understand. If two phase locking are used, then it will be difficult to find a conflict serializable schedule equivalent of that one. However, in the absence of extra information, that is ordering of this access to data, two phase locking is needed for conflict serializability also. Then suppose given a transaction Ti that does not allow two phase locking, now we can find a transaction Tj that uses a two phase locking, the schedule Tj, Ti and Tj that is not conflict serializable. Now, uh, let us study in details. How do we go for this lock conversions? Say for example, two phases of locking with lock conversions. The first phase, I acquire a shared lock. Suppose somebody acquires a shared lock on item, the data item, let it be Q. And it can acquire a lock of X. I can also request for another exclusive lock and I can acquire that one also. And then what happens? Then S is no more there because X will supersede the S. When I'm going for exclusive, the exclusive read and write operations both are there. But in the S or shared, it is only read operations there. When read and write both operations are available with me, it has no meaning that again I have to go for a shared lock S. Understand? So this is called the first phase, or we call it the growing phase. Okay, growing phase means initially I had S and I acquired the X. S because I want to write something, I want to update, then I want that one. So it can convert S to log S to log X. This is the upgradation. Okay, or I can say growing phase. Then in the second phase, suppose I release a log S and I can release a log X also. So initially I had shared log, I released that one and also release the exclusive lock which I had both for read and write, can convert X to S also. That means I had read and write operations permission was there. I want only read write is not there. So from X I can go to S. This is called the downgrade. This we call it as the downgrade. And this protocol assures serializability still relies on the programmer to insert the various locking instructions, right? Now, what is the automatic acquisition of logs? How do we go for that one? The algorithm I have written it here. Suppose a transaction Ti, it issues the standard read data instructions without explicit locking. Then how it writes? Suppose D the data item, and I go for the operation read. So read D. Okay, the operation read D is processed as how it is processed. If TI has a lock on D, then read D. What is the lock? Here I'm going for this read means only I'm going for the sad lock. You can understand. So TI has a lock on D, then read D, else begin if necessary, but until no other transactions has a lock X on D. See, I already told you that if we are going for sad lock at the same instance of time, n number of sad lock can be done on the same data item because it is not affecting anything. But suppose somebody is having a exclusive lock on the data item until it is unlocked or until it is there, so it cannot be locking or locking cannot be given to the first one, right? So the same thing is explained here. Next, we go for another thing. Suppose somebody is having a write operation. Previously, it has the read operations you see here. Somebody had the read operation. What are the things it has done here? Next time going, suppose somebody has the write operation means exclusive lock is there. If TI has a exclusive lock on D, data item D, then a write D, else, यदि नहीं ताल कौन करिवो? Else begin if necessary wait until no other transactions has any lock on D. Any lock means here it is we are talking about the exclusive because shared lock has no problem. There is no conflict. So if TI has a lock S on D, then update lock T to lock X. Suppose instead of X you are having lock shared lock you are having, then you upgrade to lock X, or then what you have to do? Or grant TJ a lock X on D, then write D, right? So once it is updated, then you end it. You can commit it or you can abort. Commit means yes, it is everything is successful. You add that one. Abort means you roll back the base ones. Now, the next part is the deadlock. What is the deadlock? Suppose we have two transactions, transaction 3 and transaction 4 that we named as T3 and T4. Now, if you study the transaction 3, suppose my data item is B. On this data item, I am going for exclusive lock X, right? So then I can read it, okay? Then I can go for operation. Suppose from B, I want to deduct $50. Okay, so B is equal to B minus 50. Then write B. So up to this, it is okay. Okay, because I had the exclusive lock. In that case, I have read it first, then I have gone for some operation. I have written that one. In the meantime, I go for lock SA. I read A, then I read E, then lock S of third lock of B. So are you getting me? Then I am putting for the lock X of A, right? So in this case, what will happen? You see, uh, exclusive lock is already there on the B. When exclusive lock is already in the B, then you cannot give another lock to third lock to others, because until it is released, you cannot give it here. Similarly, when it is already locked, third lock with a data item A, you cannot lock it to the exclusive lock to data item A. That means neither T3 nor T4 can make progress. T3 is there hanging as it is. T4 is hanging. Say, just I'll tell you, suppose this is a tunnel. You see the top part, a vehicle is passing from this end and another vehicle is coming from this end, and here only it can pass one vehicle at a time. So T3 cannot go ahead because it is stopped, and T4 because there is road is very narrow, only one vehicle can pass. T3 is not ready to go back. T4 is not ready to go back. It is a deadlock. That means somebody has to roll back, or it is to be reoriented or rearranged. Otherwise, they will hang there forever. Nobody can proceed 1 inch, right? So neither T3 nor T4 can make progress executing. Then lock SB causes T4 to wait. Here, lock SB where it is, lock SB here. What is telling? I want a shared lock on B. But it has to wait. Why? Because already exclusive lock on B item is done by T3. Until it is released, that lock, you cannot access. You getting me? So here also we are having A, lock SA. So until it is released, again he is asking for exclusive lock on that A. You cannot go for that one, right? But remember, if you are going for lock SA, you can go for that one. So that is compatible. If you are going for read, 100 times you go for read operation on the same data item, there is no problem. But because these are compatible, what is the uncompatible? At least one X is there. Here, you see, here it is one S and here is another X. SX, it is incompatible, right? So it is not possible. So this situation, we call it as a deadlock. Regarding deadlock, we'll have other videos. Uh, so I hope it has given the minimum information to you. If you like this video, please do share and also take care of your health. Goodbye.